All righty. So we're going to start chapter 2. Let's somewhat recap really quickly so far this year, right? Chapter 4, gathering of the data. So we don't see a whole lot else of it. Remember stratified, remember cluster, remember SRSs, systematic somewhat, right? Remember random assignment and a random assignment and not assignment like a observational study, right? And then also remember like who the treatments are and the experimental units and all that stuff, right? Just a lot of terminology from chapter 4, right? And then last chapter is looking at graphs, shape, center, spread, comparing them, looking at the mean, the median, the standard deviation, the IQR, the range, kind of just learning about the math of that part of it. This section 2, we want to start today. I'm not going to go really, really fast. Hopefully not enough to where you get bored with it, but this is a big one. We got to understand location and the distribution. And so this is a big deal. If you notice on the schedule, right, it only has 2 sections, 2-1 and 2-2, but I do have 2 days of review built in. This is a, you got to be able to get this one. Most everybody does pretty well on it. It's just something we got to make sure we understand, okay? All right, so the first thing I want to talk about is percentiles. And you guys probably have heard about percentiles before, about being in the whatever percent and scoring this kind of percent, that type of thing. All that's the same thing. One way to describe the distribution or the location, of a distribution is tell what percent the observations are less than that, okay? So if I know that the score is 86 and 86, I don't know, 86% on the test, right? If we know what percentile that is, or how many percent of people score below that, like if that's in the 6th percentile, that must mean everybody did really, really well, right? So this is kind of important. The percentile of a distribution, is the value with that percent. We just call it P percent. Whoops, forgot to turn on my little marker right here, and then let's go back. That percent observations less than or equal, and so that's going to be a big deal. Notice it's bolded, less than or equal to. Okay, if you, like I said, you are in the 62nd percentile. Okay, 62nd percentile. That means that whatever that value is, let's just say it's 83, okay? That means that 62% of the observations fall at 83 or below. Not below 83, at 83 or below. And that also has to mean now what? That 38% are above 83. They're not 83 or above, they're above 83. So that's the cutoff. So when I say that percentile, guys, that number is included with that percent. That number is included with that percent. And when you talk about that or they ask you to explain something like that, make sure that that's what you understand. That number goes with that percent. 84 goes with the 38. So it's greater than, less than or equal to. And that's why it says less than or equal to, okay, the percentile. Everybody good? Percentiles. Jenny scored an 86 on her test. Yay, Jenny. Not bad. Good job, Jenny. How did she perform rest of the class? So that's a big thing. That's what we like to talk about, right? Not only did she know that she scored an 86, she probably thinks that's pretty decent, but if everybody scored on 100, then it may not be very good. If everybody scores, say, 20, then 86 is really good. So a lot of times we like to compare that, right? So here are the scores of that test. Now, one thing that we didn't do a very good job, or that didn't do a whole lot is, they didn't tell me how many there are. So we got to count them. A lot of times, guys, in AP stats, I told this in the first hour, right? A lot of times in AP, we don't have to do a lot of things. They'll give us the mean, the standard deviation, the median, the mode. They'll give us all that stuff. It's our job to explain it. It's our job to explain it. We don't have to do a whole lot of math to find that information. If you guys notice on the test, you didn't have to do a whole lot to find that information. You just had to explain all that stuff. So how did she do well? Okay, so here's a 67. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's 25 test scores in here, 25 of them. And 22 of them are at 86 or below. And so I'll turn that into a percent, and I'll see that 86 is in that percentile. Okay, 86 is in that percentile. So we'll take greater than or equal to 22 of the 25 test scores, because 22 of the 25 are at 88%, less than or equal to, she is at the 88th percentile, because that 22 out of the 25 is the 88th percentile. That must mean that 22%, listen to me now, scored higher than 86. Scored higher than 86. Not 22, 12. 12, bad math. 12% scored higher than 86. 88% scored 22 or less. Percentiles. Percentiles. Good. Anything not big difficult, okay? Percentiles. Be careful with your language when you are describing percentiles. Percentiles are specific locations in a distribution, so an observation isn't in the 84th percentile, it's at the 84th percentile. And so that's kind of, again, big type deal that you'll get dinged for by saying it's in that. No, it's at that. There's a lot of things in it. Okay, it's at the 84th percentile. So big word, like I said, that it doesn't, I mean, they're both two-letter words. Big difference. Big difference. Clicky, click, click. Hit me.
Can there be decimal percentage?
You bet. Yeah, there can be. Absolutely. High percentile is not always a good thing. Do kind of remember that, right? We got a adult male who's in the 90th percentile for his age group for high cholesterol. That's not good. So not always percentiles always mean good things, bad things, right? Okay. So if we're in the 90th percentile of cholesterol, we probably need to start watching our cholesterol. Just kind of remember that type thing. Okay. Now, cumulative, relative frequency graphs. I think you should already know what a relative frequency graph is. We know what a frequency graph is. Frequency is how many times that value occurs. And then relative turns it into percentages. Well, now I'm going to do a cumulative relative frequency, meaning I'm going to somewhat accumulate that as we go. Okay, a cumulative relative, this absolutely is our last graph we have to look at. Okay, cumulative relative frequency graph. There are some interesting graphs that can be made with percentiles. One of the most common starts with a frequency table. So again, you know what the frequency table is, right? We got our values, and then we got a frequency table, how many times it occurs. And then we've turned that into a relative frequency, turns that into percentages. Well, now we're going to look at a cumulative in hieroglyphics. It's going to take, so let's just say that this is 6%, and this is 8%. Well, over here it's going to go 6%, 14%. It's going to take the previous one and add it to it. And so if the next one's 2 more percent, then we'll be at 16%. And so when I get down here at the bottom, I will be at 100%, because, listen to what I'm going to say, 100% of the data will fall at that value or below. 0% falls at to the left of this value. Okay, so that's kind of what we're looking at when we look at a cumulative relative frequency graph. We're looking at the percentages of the relatives, right, or the frequencies, and then we're going to accumulate it as we go. There are some interesting graphs that can be For instance, the frequency table summarizes the ages of the first 45 U.S. presidents when they took office. So this summarizes the first 45 presidents and their ages when they took office. Okay? Now, I'm going to simplify this, I think, for a little bit that I learned last lesson. So here's the frequency. I can turn those into relative frequency if I wanted to, right? This would be 2 out of the 45. It says 45, but I think it only adds up to 44. 9, doesn't matter. So 2 out of 44, 7 out of 44, right? Just add those up and you'll take the good. But when we do the cumulative relative, I think you're better off accumulating this. So put a 2 here, then make this 9. Now we'll make this, what, 13, 22. Add 12 more to it, that's 34. Add 7 more, that's 41. 44, it is 45. Okay with that? And then we will put 2 over 45, 9 over 45, 22 over 45. We'll do those, and then that will be the cumulative relative. It's easier to add these numbers than it is to add the percentages. It's just easier to add those numbers than it is to add percentages. You can do it either way. I just want you guys somewhat to understand that. I think that's easier. Okay? Here's a cumulative relative frequency plot. They said graph. So, important you know what this is. It plots the point with a corresponding percentile. The point with the corresponding percentile. The points are then connected with line segments. The points are then connected with line segments. You're getting ready to do one as an example. We'll do it here in class, okay? A cumulative relative frequency graph. Whatever these numbers are here, 1, 0.5, 0.25, 0.75, plots the corresponding to the percentile of the given. We're going to connect them. So whatever we decide to go here, we always start at 0, right? And at some point, we'll have a point. It'd be whatever percentile that is. Whoa, that was loud. Okay? So let's is anybody still writing that definition? Y'all good? I went too fast. Go ahead. Take your time. I went too fast last hour. Okay. Plots a point corresponding to that percentile of the given value, then those points are connected with line segments. Cumulative relative frequency graph. We just went over the cumulative relative frequency table. We're going to convert that to a graph. Pencil, pencil, pencil. Good, 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 good. Okay, here's the presidents. Back to it, okay? Frequencies. 2, 7, 13, 12, 7, 3. Relative frequencies. Again, I don't do those. If they ask for relatives, I do, but I don't. I go to the cumulative frequencies. 2, 9, 12. I guess I did really bad math because I ended up 45 last time. Oh, okay. So we're going to go with this one for now. Everybody okay? And then I'm going to turn those into percentages. Turn them into percentages. So this is 4.5%. Typically make that 0.045. Make this 0.205, 0.5, 0.773, 0.932, 1. You should always end at 1. If you don't end at 1, you've done some bad math. Because 100% fall at 69 or below. Okay? 0% fall at 40 or below. 0% fall at 40 below. So then here's what I would have, right? I would have this little number chart, and I would start somewhere. I'll start at 40. And then they went by fives, okay? So 45, 50, 150, 50. At 40, I'm at 0 because nobody is below 40. When I get to 50 or 45, I'm sorry, when I get to 45, I should be at that 0.045. 0.045, and then I connect it with a line segment. When I get to 50, I should be at 20%. 20%. Connect it with a line segment. Kind of makes sense, good? To where it ends up looking something like this. They will all look close to this. They will all look close to this because they will all do what? Start at 0 and end at 100. So they're all going to kind of look like this. They will never go down. They will never go down because you can't go from that percent down. Okay? So here's some things you need to know. Everybody okay with that plot? Good? If you're asked to describe that distribution, don't say it's skewed left because you don't know right off the bat. Okay? All of these look like this. So they all kind of look, I want to say it's skewed left, but they're not. When it's flat, that means there's not a lot of data between there. Right? And we said it. There was only 2% from 40 to 45. There was only 2% from 40 to 45. However, from 50 to 55, that was 30% by itself. That one was steep. The steepness implies how much percentiles in that, right? Because we ended up going flat again. This one's actually unimodal. It starts a little flat, starts becoming high, and then becomes flat again. So if it was flat, high, and then flat again. Kind of see it? One of the hardest things for students to do is to turn one of these into a regular graph to describe the distribution. Okay? If it's really steep at the beginning and then flares off, that one will be skewed to the right. Because as you get to bigger numbers, there's less people or less data values. If it starts off almost flat and then starts going up fairly quick, that means there's more at the higher end, less at the lower end. Okay with all that? Kind of makes sense? Again, when I made a cumulative relative frequency plot, I don't do this one. Okay? What's nice about these is what? I can find the 50th percentile pretty easy. 55. 55 is a 50th percentile. I don't have to do a whole lot of math. Don't have to do it. It's right there. The IQR. 25th percentile. Oops, that wasn't very straight. 51, 52. 75th percentile. 60. 60 to 51. IQR is 9. Good enough with all that kind of makes sense? By the time I get to 70, I'm at 100%. 100% or 70 or below. Yay? The thing that messes up is people at the start, right? Don't start until I get data values. This value will always be 0. The 40 will be 0 because nothing is there. By the time I get to 44 or 45, I guess technically 45 because it's that number or below, I should be at 4.5%. I should be at 4.5%. By the time I get to 50, which is here, then I should be at 20.5%. Yay? 50th percentile, here we go. Let's see if you guys can learn anything. Beautiful. Here, 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 here. Whoops, sorry, here, 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 here. Here, here, here. That might be 3. Oh, that's just 2. There's 3. 1, 2, 1, 2, 1, 2, 1, 2. I don't care if you make the tally marks. The tally marks are for you just to, like the first one you see 40, go to 40 and put your little tally mark if you want to. I don't really care if you make the frequencies. However, you probably need to. I don't make the relative frequencies. I skip that one, but you got to get to the cumulative relative frequencies, the far right. You got to get to the cumulative relative frequencies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 19. Who we decide was not here? Oh, that's right. Milan. Should be 6. Yep. That's kind of important for this class.
So we count how many is from 11?
Yep. Yep. Good start. So far, all the numbers I'm seeing are correct, minus somebody who said what they were. Good. Good. Yay. What's the next number? Oh. Oh, good. She's way ahead of you.
Well, I'm not good at
Oh, good numbers. Oh, we're losing the tally mark. So good. Now where are we at? Oh. Uh-oh. I think the last two are off. I think. I'm going off memory. I thought it was 13, 12, but I might be wrong. I might be wrong. I'm going off memory. Yeah, that's what. What you got? 6, 9, 13. I think that's what it is. Okay. I'm going off memory. Play ball better than brother, but can't count better than brother.
Okay.
I mean, all I'm doing is gathering evidence. That's all I'm doing is gathering evidence. Yep. Good numbers.
I think it's actually going to get a question like this. We have to spend about 6 minutes.
Nope. Nope, they'll do it for you. What'd you end up with? 6, 9, 13. Yep, no, you're right. So your frequency should be 6, 9, 13, 12, 4. 6, 9, 13, 12, 4. And then from there, I will go ahead and do a cumulative frequencies. I'll skip the relative frequencies. And then I'll turn the cumulative frequencies into percentages for the last column. Well, you're getting ready to have to graph it, so I don't think you're going to notice a whole lot of difference between 0.1 and 0.8.
Like when we're writing. It's when you're holding up.
6, 15, 25, 40, oops, 40, doesn't go, and 44.
I think that one's 28, the third one.
L1 divided by 44. Is it 44?
Yeah.
That's pretty neat.
Just a quick question. Understanding frequency. Would it be 3? The first
No, the frequency is 6.
6. Okay.
The tally marks, those should have been tally marks.
Always start with 6.
I mean, however many there are.
And
The
then
frequency is telling you how often it occurs.
whatever 6, whatever it takes to get to 9. So
That would be the cumulative frequency.
Okay. So this is just 6 plus 9.
Mm-hmm.
Ogive. Ogive.
Ogive. That's the plot. That's what it is.
Oh, okay.
That's what they use. They call it that. AP doesn't use it much. I thought I said it already, but I didn't. That was previous class.
I'm a little confused.
About?
Are my numbers right?
I think so.
So what do I do here now?
Plot them
Well, how do I do that?
correctly.
No, like, can you just help me start? Like 14. With this go? This is 11 to 20. Is it gonna be like a histogram?
No, it's going to look like.
I was thinking
That's.
I don't.
Well, you got an X column and a Y column, right? DRP scores
Yeah.
and a cumulative relative frequency.
Range?
Mm-hmm. Mm-hmm. So by the time you get to 20, you better be at 14%.
Oh, so I don't have to worry about like each individual.
Correct, because we don't know those values. Cool. Uh-oh. So we get to 10, we're at 14% or 10 or below?
Starts at 11 through 20.
Your graph says when we get to 10, they're at 14%, so 14% are 10 or below.
So it would be this as well.
No, it's still showing at 10, you're at 14%. At 10, I don't think you have anybody yet. 10, you're still at 0.
So how would I rank that?
Uh-oh. Oh, you got there.
Wait.
Kind of a little messy, but you got there. Uh-oh, why
you
you
made
got...
the same mistake.
When you're at 10%, guys, you're at 0 still. I'm sorry, not 10%. When you are at DRP score 10, you're still at 0%.
You use the first one then? When you, like, how do you know where to put the dot? Do you just use this first number? Since it's like a range?
Kind of, yes.
Okay.
But at 10, you should be at still 0.
11 through 20. Did you put it at 90?
Right, when I get to 20, I'm at 13%, 14%. When I get to 20, at 10, I don't have anything. Nothing's below 10.
Right, so I should do my dot at 20.
So you're off one. Yep. that make sense? Beautiful. Yes. I mean, it's an estimate, but yeah.
Did I do that right though?
I think so.
Okay.
You just go straight across. Beautiful. So the 20th percentile is going to go where? 20%, straight across, straight down.
That's right, maybe.
So at 10, I don't have anybody at 10, so we're still at 0.
0%, yeah.
When I get to 20, I should be at
13.6.
so 14%. So when I get to 20, I should be at 14%. Yep. You figure it out, Dashel? Yep.
So for the 20th percentile, do you just do like 44 times
No, no.
0.2?
I'm just going to go straight across the 20 and go straight down.
Oh, that makes more sense.
Guys, understand when you get to a certain point on these, right, it's going to be a lot of estimating. So there'll be some wiggle room on some of this, right? You might be 1 or 2 off from your buddies. It's all okay.
Oh, it's like 50 exactly, right? Just under, but I think 50 is fine. Alright, just under, bro. So the median is just yeah, 37. And then
About. That's fine. That's fine. The back is more important than the front because you won't ever have to make one of these, right? You just got to know how to read them. Good. You got it there. Cool. Yeah, at 10, you're at 0. And when you get to 20, you should be at 14%. Mm-hmm. Beautiful. It shouldn't be linear, though. You should have line segments. So at 10, I'm at 0.
Yeah, it differs very slightly, right?
Right, but there's nothing below 10. So 10 is 0.
Okay, yeah.
When I get to 20 is where I should be at 14%.
Yeah.
So at 20, I should be at 14%. That's 20%. There's 14.
At 20, you're at 14%, which is here.
And when I get to 30, I better be at 24%.
You get to 30.
Or 20, yeah. And that's 20%. So it, are you with me?
Okay, wait. So
Here, fat fingers. So nothing is below 10.
yeah, I get that.
So when I get to 20, I better be at 14%. Well, that's 20%. So this is 10%. So 14 somewhere in here.
Okay.
When I get to 30, I better be at 24%. There's 20, there's 30, so somewhere in here with my bad eyes. And then you're going to connect those with line segments.
Okay. Thank you.
You're welcome. And so when you get to the end, you should be at 100%. Yep. You're good? Sounds like it.
Because I made the graph based off of this too. And
For the IQR.
Hers is not 10. Oh wait, she didn't do it.
Was mine right?
I don't know. 25% and 75%.
Well, like, I get that, but like, is the number?
I don't know. I didn't do it.
You do know, you're the statistic.
No, I didn't do it.
The teach should know that what's right.
25%. Look at that number.
I did that.
75%. Look at that number and subtract them.
There should be like an AP counting. And like AP.
Yeah, but for $2,000, you can get a million, bro. For $1,000. They're good.
Me and Emily are gonna leave in about 5 minutes. Very excited. Is there anything I need to just make sure?
Yeah, we'll finish the notes and
Okay. Is the video gonna be posted by then? Okay, I'll just watch it.
probably want to wait till we get, because all this is recorded. Fast forward all that.
Yeah, no, that's a nice for the.
Is this, are these the questions for?
We're getting ready to talk about it.
So
We'll
they're,
talk
are
about
they for the graph or like?
Anytime, general. Yep, in general. Hey guys, I've mentioned some of you guys, the back, remember I've told you guys you're probably not going to have to make one of these on the test, right? You're not going to have to on my test. You just got to know how to read them. The back is more important probably than the front, or not necessarily the making of it, okay? But those questions where they're going to ask you the 50th percentile, the IQR, those questions, and then the very last two questions are really important according to the test that I just looked through for next time. Hint, hint, hint. So we'll discuss it in a second. On the back page. Oh, it should never go down.
Oh, never go down?
No, it should never.
Oh, then I might have calculated my last one wrong.
34, 63, 90 should be 100. That should be 44 over 44.
Oh, 44 over 44 is 100?
Huh?
I didn't know that.
Anything over itself? 44 over 44?
Mm-hmm. That's what it said. Hold on. I might have done it wrong.
Probably. 44 over 44 is 1.
Oh, yeah.
Every day and twice on Sunday.
It disappeared. This is what I meant to do.
Can you tell me if I got these two right?
I don't know. We're getting ready to go over it. I may ask you.
No, do not.
I might.
You know, I had a flex that we were doing a nature walk and picking up trash on the greenway behind the school, and we came back. If you don't trust me, you know.
I got you. I probably sent one out. All right, guys. Ears for, let's finish up this lesson. Those questions, I'm assuming, like I said, within one or two, those 50th percentiles, right? Not everybody's going to have the exact same number, but if you're within one or two or even 5, you'll be okay. The last two questions, okay? The last two questions, those are on the test, right? If it is flat or somewhat flat, that has to mean that what's between that interval? Not very much data, right? Not very much data. If it's steep, like this one right here, where I'm going from 50 to 55, and I went from 20% to what? 50%, that's 30% is between 50 and 55. That's a lot of data. 30% of the 100, 30 points fall between here and here, 30%. So when it's steep, it contains a lot of data, and when it's narrow, it doesn't contain a lot of data. It's almost no data. If it's flat, there is no data. There's no data. But that's why I'm saying this will never go down, because we can't have negative percentages. right? Once we start to a certain percent, we're there. We don't go down to a percentile. You can't go from the 50th percentile to the 40th percentile. We have to continue to go up always or stay constant. Okay? Any questions about a cumulative relative frequency plot? They used to call them ogive. That was that definition at the bottom of the first page. It looks like ogive, ogive. Everybody okay? Yes, no, maybe. Here we go. Let's finish notes. Let's finish notes. All right. I've mentioned this a couple times, right? They always start at 0. They always start at 0. They always look somewhat, I want to say skewed left, but they're not always skewed left, right? Because it depends on what the values are. That one would be bimodal because there's a lot of data here, no data, a lot of data. That would be bimodal, okay? We did the worksheet, okay? All right, now let's talk about z-scores. Z-scores. And, I know I talk about a lot of things being important. If you don't get this, guys, we're not going to do well the rest of the semester. Z-scores are something you have got to understand. You may have heard it in some other class before, but we're going to talk about what a z-score is. We have to know what z-scores are, okay? Z-scores. A percentile is one way to describe a location of an individual. You're in the 86th percentile. You're in the 27th percentile, right? Another way to describe it is called a standardized score. And because we're lazy and we don't like to write standardized every single time, we changed it to a z-score. So Z means standardized, okay? Z means standardized. So here's what the z-score is. Here's the definition. A z-score tells us how many standard deviations. How many standard deviations I think I said it backwards. So from the mean, an observation falls. How many standard deviations from the mean a value falls? And what direction? Whether it falls above it or below it. Whether it falls above it or below it. A z-score tells you how many standard deviations from the mean the value falls and what direction. X bar equals 80. That must mean that the average is 80. Good enough? Standard deviation is 10. You need to know that the standard deviation is what? The average distance from the mean all the values are. That you got to know. One person, one value is at 90. One value is at 90. Well, what do we know about 90 compared to 80 compared to the 10? It's one standard deviation above the mean. So this z-score is 1. That z-score is 1. What if I tell you that the value is 70? That is also one z-score away, or one standardized score, but it's in the left side, so this z-score will actually be -1. Because we can now assume what? If x equals 80, how many standard deviations is that away? 0. That is 0 away. So the z-score tells us how many standard deviations away the point is from the mean. And what direction. Positive means we're above it. Negative means we're below it. And of course, 0 must mean that we fell right on it. Okay with that? Here's the formula to find the z-score. It's the value minus the mean I use letters for this, guys. I say Z is equal to X minus X bar over S. And if you want to put the sub X, you can, just to somewhat maybe help you. You got to know this. You got to know this. You got to use this. You got to know this. This is not on your formula sheet. It's easy when it's nice, clean numbers like the ones I just did. Very few times are they nice, clean numbers. Very few times are they nice, perfect, clean numbers. Y'all okay with what z-score is? Z-score, you got to just have that in your head. You know what the standard deviation is? The average distance from the mean. That's what the standard deviation is. It's the average distance from the mean. So if the standard deviation is 10, that means the average distance away from the mean is 10. The z-score is that one value. How far away is it? How many standard deviations is it away from the mean? It could be right on the mean. It could be above the mean. It could be below the mean. Y'all okay with what I mean by z-score? I'm spending a little bit extra time making sure, but I've gone through this a little too quick last couple of years and it's killing them. You got to understand what the z-score is. It is the standardized score. And the reason why it's standardized score, because we're talking about the standard deviation. It's always that value, whatever it is. Whatever that value is we're looking for, we're going to subtract the mean from it. Yes, you can have a negative, right? If the mean's 80 and this is a 70, it's negative 10 because you're below it. Jenny scored that 86 on the test. She scored an 86. The class mean is 80. Beautiful. When it gives me something, I'm going to tell you that. In fact, I could do this, I guess. Right? Because her score is 86. X bar is 80, and the standard deviation is 6.07. Good enough with that? This is 6.07. This is 86. This is 6 away from this. This is 6.07. Whoa, she got what? Really close to being one standard deviation above the mean. Let's calculate exactly how close she got. Find and interpret the standardized score. AP question. Find and interpret. So we're going to find it. We're not going to have a naked number, right? She has an 86. We subtract the mean of 80 and we divide it by 6.02. Let's talk calculator etiquette because I have seen students do this before. 86 minus 80 divided by 6.02. Wrong. Your calculator will do 86 minus 80, 80 divided by 6.02. I don't want 80 divided by 6.02. I want 86 minus 80 divided by 6.02. So do one of two things. 86 minus 80, enter, divided by 6.02. Or 86, or 86 minus 80 in parentheses. Good? Am I saying something wrong? You're kind of giggling. Okay. You're good? Okay. Oh. Okay. I thought I said something wrong the way y'all looked at me. Fix it. That's okay. I got dyslexia. I got issues. I don't know how to read. 0.99. What did we say? Really close to 1, right? Really close to 1. If you put 1 on a test, are you going to get wrong? If you put it is 1, yes, you will. About 1, you'll be okay. Yeah, fair enough, right? We talk about that a little bit. If don't put that it is 1, if it's not 1, it's almost 1. And then they want you to standardize, or I'm sorry, to interpret this. So that's where you're going to have to write this in words. Jenny scored almost 1 standard deviation above the mean. Jenny scored 1 standard deviation above the mean. And guess what happens if you don't put the word above? You're getting dinged. You're getting dinged. Guess what happens if you just put 1? You're getting dinged because they don't like what? Naked answers. Jenny's test score is almost 1 standard deviation above. Notice that the above is in bold letter because they grade that part. I knew I was above because the score, she was above the mean. So I knew she was above, but we still have to state it. If she scored below an 80, she'd be below the mean. Yes, no, maybe. Z-score. Huge importance to know. Huge important to know. That's how many standard deviations away a value is from the mean and what direction. You have to just know that, okay? Like I said, there's only 2 sections in this test. That's a big part, the Z-score. Z-score. Caution, do not interpret the Z-score as a way. Tell me it's above or below. Don't say it's 1 standard deviation away from the mean. That's not good enough. That's not good enough. Above or below. How do I know? If the number's bigger, you're above. If the number's smaller, you're below. If you have a positive, you're above. If you have a negative, you're below. What if the Z-score was 0? That means what? That value is the same. It's a mean. That value is the mean. Okay, last thing we need to talk about today. And I think I did better first hour than I've ever done this before, just rather than go through some notes, I just started talking about it. So you have to use your mind. I'm drawing my hands, and I have a bar graph. I'm sorry, a box plot of your test scores. Yeah, okay? I got a minimum, I got a maximum, I got the IQR, and I got the median. All right. I add 10 points to everybody's test score. I add 10 points to everybody's test score. What's that going to do to this graph? Shift it 10 units. Bigger? Smaller? Median, is it going to change? Mean, is it going to change? Most definitely. If I had 10 points to everybody's score, the mean's going to change, right? What about the IQR? No. Q3 and Q1 change, but the IQR does not. Range, still the same. However, the minimum and the maximum are now changed. Good enough for that? If I subtract, y'all must have really ticked me off if I decided to subtract something, but if I did, all that's going to do is shift the whole thing down. Going to change what? The median and the mean. We don't talk about mode. IQR, yes, no, it doesn't change the IQR, right? It changes the mean and median. It does not change the IQR. It will not change the range, and it will not change the range standard deviation, because all I did was shift it. All those values are still that far away from the mean. Good enough with that? So this is called linear transformations. You guys, most of you guys had pre-cal at some point, or at least algebra 2 at some point. We talked about transforming data and transforming graphs, right? You got the parent graph, and you've got the transformations of those parent graphs. We move them up, move them down, move them left, move them right, do all that kind of stuff. Well, we're going to transform data. We're going to transform data. Transforming converts original observations from the original units to some other scale. And they'll do this often, okay? Transformations can affect the shape, the center, and the spread of a distribution. So, the effect of adding or subtracting a constant. We just went over this, right? Adding or subtracting the same positive number. I can't imagine, I don't guess you're going to add a negative number, because if you add a negative number, you might as well subtract. And I for sure don't think you'll ever subtract a negative. To each observation. Well, here's what you need to know about it. It adds or subtracts that same number. This is a variable A. Okay, that's a variable A. To the mean and the median. Because the mean and the median are going to change whatever that value is. If I add 10 points to everybody's, the average has to go up 10 points. The median has to go up 10 points. However, what we just said, and you guys told me, it does not change the standard deviation, the IQR, or the range. It does not change those values. It does not change those values. Because all it did was just shift it. It didn't make it bigger, didn't make it smaller, it just moves it. Moves all my data. Again, Q3 does change and Q1 changes, but the difference doesn't change. Okay, that's adding or subtracting. That's adding or subtracting. Now a little bit far-fetched, right? Multiplying or dividing. So I'm going to take all your values and multiply it by something. That's not only going to move it down, but it's also going to expand it. Because now if this average was 4 and this was a 6, now this is an 8 and this is a 12, it got further away from the mean. Right? It got further away from the mean. Therefore, it's going to change the spread. So, oh, it does not change the shape. I'm sorry. It does not change the shape. Sorry. We always talk about shape, center, spread, shape, center, spread, shape, center, spread. So it does not change the shape. It does not change the spread. It does change the center. It does change the center. Okay, now the multiplication. It's going to multiply or divide the mean and the median. If I'm dividing, it's going to divide it. If I'm multiplying, it's going to multiply it. Both the mean and the median. But not only is it going to change the mean and the median, it's also going to change the range and the IQR and the standard deviation. It will change all three of those. So now we know this, right? Multiplying changes the center. It also changes the spread. Addition only changes the center. Now, I said it doesn't change the shape. It doesn't look exactly the same, but if the population skewed right, it's still going to be skewed right. It's just going to be stretched. If it's going to be bimodal, it's still going to be bimodal. It's just going to be stretched. So the shape, notice how I said does not really change. Yeah, it doesn't look exactly the same, but the overall shape is the same. If it's uniform, it's still going to be uniform. If it's bimodal, it's still going to be bimodal. It's just going to be spread out a little bit more because we're expanding everything. Y'all okay with the transformations? Addition, multiplication. Addition, subtraction. Multiplication, division. Multiplication and division changes everything but the shape. Addition only changes the center. Okay? A highly missed question on the test. I'll try to remind you guys when it gets closer, but it came from one of your homework questions. All right, let's look at this. Soon after the metric system was introduced in Australia, a group of students was asked to guess the width of your classroom to the nearest meter. So picture you guys in Australia, and I'm asking you to guess the width of this room in meters. I couldn't even guess in the feet, much less meters. A dot plot of the data and some numerical summaries are shown. This is very common. They don't want you to do all this stuff. They're going to give it to you. So they give you the dot plot, skewed to the right. Some people have really, really high guesses. I've got a cluster of guesses here. They tell me that there were 44 students in the class, or at least 44 people answered this. They tell me that X bar is 16.02, so 16 is the mean. They tell me that standard deviation is 7.14. They tell me the minimum. They tell me Q1. They tell me the median. They tell me Q3. They tell me the max, and they tell me the IQR, and they tell me the range. I don't know what else I would want. I guess maybe, no, they even gave me the IQR, didn't they? I don't guess there's anything else I would want. Everybody okay? The actual width of the room is 13 meters. The actual width is 13 meters. So these guys underpredicted it. These guys overpredicted it. Those guys way overpredicted it. Okay with all that? So here's what they tell you to do. We can examine the distribution of students' error. Like how far off were you? Rather than what your guess was, how far off were you? The new variable shows you. So here's what they're going to do. They got your error, the guess. Well, we know what the guess was. That was on your dot plot, minus 13. So what am I basically doing to all those points? Subtracting 13. I'm subtracting 13 to all those points. Note that the negative value for an error indicates that the student width was too small. They underpredicted it. What shape does the new distribution have?
Same.
Same. Skewed to the The new distribution is skewed to the right. The new distribution is the same, which is skewed to the right. Here's their answer. The same shape as the original distribution of guesses, skewed to the right with two distinct peaks. I don't think I'd talk about the two peaks. I don't know how two peaks that is. But skewed to the right, that's a no-brainer. It's for sure a no-brainer. It's skewed to the right. What? Oh, I'm sorry. Find the mean and the median of the error. Well, if I subtracted 13 from every single point, the new mean is going to be 16.02 minus 13. The new median is going to be 15 minus 13. You guys being smart students know what? You can't put a naked answer. So just show those subtraction problems. Just show it. Show 16.02 minus 13 equals 3.02 meters. Put it in context. Don't get in so much of a rush that you guys, I'm telling you, the how you do this and the way you word it is more important than the 3.02. I guarantee that if you put 16.02 minus 13 equals, I have no idea, I do not have a calculator, but it's going to be in meters. They'll give you full marks. By the time you write all that stuff, you can just put the number, right? 15 minus 13 equals 2. I know every one of you guys can do that in your head. Don't. Show it. Show it. The how and the answer, not really the answer, the how and the context is more important than the answer in this class. Everybody okay? Good. Let's see. What does it say? It is not a surprise that the mean. It's not a surprise that the mean is greater than the median. Why? Why is it not a surprise that the mean is greater than the median? It was skewed which way? To the bigger numbers. So the skewness does what? Pulls the mean. Should I write that on a test? Probably not. If I do, is it going to be wrong? No. If I write it and it's wrong, is it going wrong? Yes. Now it wants me to find the standard deviation in the IQR of the guess or of the error. Well, what did we learn about the standard deviation in the IQR? It's not going to change. It's not going to change. The same for the original. So it's still going to be 7.14 and the IQR is still going to be 6. Good? All right. Last thing. Sorry. Because the students are having some difficulty with the metric system, I can't imagine that. It may not be helpful to tell them their guesses tended to be about 2 meters too high. I think it was 1.62. Let's convert this error to feet. And so it says there's roughly 3.2 feet in a meter. Therefore, 5 meters or negative 5 meters times 3.28 is negative 16 feet. So basically, I'm taking all these errors and I'm going to multiply them by 3.28 to figure out what it is in feet. So what's the multiplication going to do? Everything except the shape. What shape does the distribution have? The same, still skewed to the right. Find the median of this new. So I would take that median, 15, and multiply it by 3 point whatever it was, I forgot. And the interquartile range, I'll take the IQR, which is 6, and I'll multiply it by that 3.28. So the shape will stay roughly the same. 2 times 3.28 is now 6 or 5.65. 6.56 feet, because we're now in feet. 19.68 feet. Yes, no, maybe. Starting to see a little bit more math and a little bit more numbers and a little bit more of what's happening with statistics and the numbers. Okay. I hope that you can find and interpret the percentile of an individual data by using the Ogive or the cumulative relative frequency. I hope you can estimate percentiles by using the cumulative relative frequency. And then I hope you can find and interpret the standardized z-score from a distribution of data. And then I hope you can describe the effects of adding and subtracting, multiplying and dividing to all the data sets. Yippee, yippee, yo. Not too difficult, I hope. We'll see. So we're going to hit this, and we're going to hit this, and we're going to hit this, and we're going to hit